Oh, hola, ¿cómo está? Welcome to lesson 3.7, Systems of Equations. Today our objective for students to be able to find the points of intersection between a parabola and a line. What's a parabola? You're about to find out if you forgot, because you might know it. Let's start with this question. What is the point of intersection between the line AB and CD? So we got AB and CD over here. What is the point of intersection? Well, if you look over, they intersect right here. And I call that point 1, 1. So the point of intersection is 1, 1. Another way of saying this, where these two lines intersect, would also be called the solution to this system of equations. Now, a system of equations is just when you solve more than one equation. Solve more than one equation. So if you see here, we really have like two lines or two equations. And where they meet is the solution, because it works for both of them. So 1, 1 would be the point of intersection, or the solution. You could say it either way. Now, this is something you probably did last year in algebra. We're about to get a little more complicated. What we're going to be doing is looking at the graph of a parabola and a line, or a quadratic and a line. And that's this U-shaped thing and a line. Now, looking at this, remember, a point of intersection is called the solution. So how many solutions are in each of these graphs? So if I look at this first graph, I would say that there's 2 points of intersections. So I would say there's 2 solutions to this, right? There's 2 sets of points that are both on this line and on the parabola, that U-looking thing. For this one, the U, or the parabola, and the line don't intersect, so I'd say there's no solutions. They don't intersect, so they share no common points, and so there's no solutions that solves both of them. And then finally, if you look at this guy, there's just 1 point over here where they touch at the bottom, and that 1 point where the U and the line touch, that would mean there's only 1 solution. So basically, how many points of intersection tells you how many solutions there are. All right, why are we dealing with this? Well, they were really looking at how to solve these systems where you have a quadratic or a parabola and a line. Now, one way to do it is graphically, and that's really what we're looking today. Now, you could do it algebraically, but I'll save that for next year's teacher. Ms. Samaru's got you on that. I'm going to be teaching you how to do it graphically. So over here we have a parabola and a line, and they intersect at 2 points. And the question I have is, what is the solution to the systems of equations? Okay? Well, all I have to do is look at the 2 points. I have my first point over here, and that's point 0, 0, so that's my first solution. And I look at my other point, it's 2, 4, and that is my other solution. So this system has 2 solutions, 0, 0, and 2, 4, and that's it. That's how you solve this. I found my solutions. Just where the points intersect, the lines intersect. Now, fun fact, I've said it 9 times. What is this U-shaped thing called? It's called a parabola. Get that in. If it's a U-shaped thing, line, it's a parabola. Okay, so let's look at 2 problems. Now, we're not going to be solving these algebraically, like I said. We're just going to graph these 2 equations, find out where they meet, and those are our solutions. So let's look at this question. What is the solution to the following systems of equations? We have y equals x plus 3 squared minus 4, and y equals 2x plus 5. So what we need to do is graph both of them. Now, if you look at these, this guy over here, it has a squared. And so that makes it a little different for us. We haven't learned how to graph this guy yet. So what we're going to do, we're going to put the one with the squared in the calculator and graph it there. Calculator. All right? Because this is a parabola. This is our parabola. If it has a squared in it, you're going to see a parabola. Now, this guy, this is a linear equation. That's a straight line. So we do know how to graph that. And all we have to do is, well, 5 is our y-intercept. So 1, 2, 3, 4, 5. That goes right here. And has a slope of 2. So up 2 over 1, up 2 over 1, and we're going to draw our line. So we know how to graph this guy. That's good to go. Up 2 over 1, up 2 over 1. Okay. So that is our first line. And you know what? Sorry, let me color it. I know I'm being annoying, but I just like giving things colors. It makes it nice and pretty, and we can distinguish it. Let's make that one blue, okay? So that's this, y equals 2x plus 5. And I'll even label it y equals 2x plus 5. Now we have to graph our parabola to know where they intersect and find the solution. So how are we going to do it? Well, you should break out your calculator right now. I'm going to break out mine. Boom, there it is. And we're going to put that graph into the calculator. So excuse me while I look back at what the equation is. It's x plus 3 squared minus 4. Okay, so it's x plus 3 squared minus 4. You press enter, and that's what it looks like, okay? Now you could just try to kind of graph what it looks like and eyeball it, but that would be an awful way to do it. So what you're going to do is actually find out what these points are. And the way to do that is you go to your calculator and you click on the menu button. From here, go to table and then split screen table. So once again, menu, table, split screen table. Done. And you'll look over here, this is your table values. You have your x and you have your f of x. And that basically means your x and your y. So over here are all your x values, and over here are all your y values. And I want you to go up to -8. That's a good place to start. And what this doing is basically giving you points. Your first point's -821, -712. These are all your points. So I'm going to copy these, okay? What you want to do is copy these onto your paper. These are your points. So -712, -65, all right? And I'm just going to copy those over right now. So all I did was I copied all the x and y values, or x and f of x values down over here, and these are my points. So my first point is -6, 5. So I go to -6, 1, 2, 3, 4, 5, 6. Up 5, 1, 2, 3, 4, 5. I graph my first point. My next is -5, 0. That's my second point. My third point is -4, 3. -3. -3, -4. -2, -3. -1, 0. 0, 5. And let's see. Is there anything else I'm missing here? And, oh yeah, 112. 1, and that's all the way up here. So I'm just going to draw what that kind of looks like, all right, over like this. Oh, that's a gross looking graph, but there it is. That's my parabola. Oh, I hate that. Hold on, let me try it one more time, just because I think I could do better. Whoa. Beautiful. And sorry, I just have to adjust one thing. I didn't actually draw this perfectly. There we go. Okay. Now, I've actually drawn my two equations here. I just took my table values, did my graph, and now I can find the solutions because that's just where they intersect. So I have my one solution over here, and that is at 0, 5, 1, 2, 3, 4, 5. So one solution's at 0, 5. And this has another solution over here, and that's at 1, 2, 3, 4, down 3. 1, 2, 3. And that is -4, -3. Okay, for our second problem, we are going to be solving the system's equations graphically. And what you'll notice here is that we can't graph them yet because they're not in graphing form. For them to be graphing form, they have to be y equals. And neither one of these has y isolated so we can graph it. So we're just going to have to solve them for y. So let's start with the one we know how to do. We've done this a few times. Y minus 2x equals -2. Put the line down the middle, and we're going to add 2x to both sides. Add 2x, add 2x. That cancels out, and we get y equals 2x minus 2. Now for our second equation, x squared minus x equals y plus 6. We need to get y by itself, so we're going to put a line down the middle. And we got the y on this side, so to isolate it, we're going to subtract 6 from both sides. When we do that, y comes down, the 6's cancel. And since I can't subtract 6 from either one of these x squared or x, it's just x squared minus x minus 6. And those are our two equations we're going to use. Y equals 2x minus 2, and y equals, you could switch it, it doesn't make a difference, x squared minus x minus 6. All right, to graph, our first one is just -2 is our y-intercept, and we know that slope is 2. All right, we draw our line. Going down, start over here, and it goes right through like so. Okay, perfect. And you know what, let's make it blue. Now, I don't think I did this in the last one, but you got to remember to draw arrows on either side of it because these do go on forever. So if you don't put the arrows down, it doesn't indicate that they go on forever, and that would be wrong. And you know, it might even take points on a test. The second one, we've got this covered. Now the second one is a parabola. What we're going to do is just plug this into the calculator and get the table values. So going back here, hold on one sec. Whew. Ooh. What we're going to do is plug in our graph to the graphing calculator. So x squared minus x minus 6. We go back and we get our table. And what we're going to do is just record the values that we see. Now it's good to go back until the point where you can see that you graph it. Now -636 is not something we put on our graph, so we don't have to worry about that. -524, also too big. -414, too big, but if we go down just a little, at -36 we can start copying. So let's copy these values, because that is what can fit onto our graph. Okay, we copy over our points. And once we've copied our x and y, we just have to plot them. So we got -3, 6, and -3, 6, 1, 2, 3, 4, 5, 6, -2, 0, -1, -4, it's over here, -0, means 0, -6, 1, -6, 2, -4, and 3, 6. 1, 2, 3, 4, 5, 6. Okay. So we just have to graph this now. We graph it. Goes down through here, over, up through here. And that is how it's done. Now this is super ugly, but we can still see our points of intersection. We have one point over here at -1, -4, so that's one of our solutions. -1, -4, and one more at 3, 1, 2, 3, 1, 2, 3, 4, at 3, 4, which is over here. 1, 2, 3, 1, 2, 3, 4. All right, guys, that is it for this this lesson. Just remember, you just graph them, look for your points of intersection, and you're good to go.